In section 1.2, day 3, we continue on with histograms, and this time we're going to talk about the relative frequency histograms. So how is a relative frequency histogram different than a regular histogram? So these words here, relative frequency, is talking about percents. So whenever you hear those words or see those words, think of it's always percents of something. So it's a histogram that shows how often something happens in percentages, as opposed to amount. So not how many times does it happen, what percent of time does it happen? We only have a couple examples. So complete the chart below by finding the relative frequencies. So if we're given the age group, the number of people, we're trying to find the relative frequency. So the first thing we do here, step 1 is find total number of people. So find the total number. So we're going to add up all of these. So if we add them up on a calculator, we end up with 150.9. So about 150.9 million people. And this is the residents in the U.S. in 1950. So the relative frequency is what percent of people are there in there. So to find the percent or the relative frequency of people under the age of 10, you would take the number of people under the age of 10, so 29.3 million, divided by how many people there are in the entire country. So 150.9. And the relative frequency is 14.4. Actually, let me just do this. Oh, there's no calculator there. I believe we get 14.4%, which would be, it's 0.144, which is 14.4%. And then we do the same thing. And actually, excuse me, I had a poor handwriting. This should actually be 0.19, which is 19. Let me fix that. Should be 19. So it's 19.4%. Okay, in the age group of 10 to 19, it would be 21.8 divided by 150.9, which would be about 0.144. This is where I was reading. This one is about 14.4%. Okay, the next one would be 24 divided by 150.9. Which would be about 15.9%. 0.159. Okay, and you'll continue on doing the number of people divided by 150.9. The next one, the class of 30 to 39, would be 22.8 divided by 150.9, and you would get about 15.1%. Then 19.3 divided by 150.9, and you'll get 12.8%. 15.5 divided by 150.9 is about 10.3%. And the next one would be 7.3%. And then 3.6. The 3.6 would be, again, how we're doing this. I'm not writing every step down, but it would be 5.5 divided by 150.9 would be 3.6%, which was, just so we're aware, 0.036. 0.036 is 3.6%. And then 1.6 divided by 150 is 0.011, or 1.1%. And then 0.1 divided by 150 is equal to 0.001, which is equal to 0.1%. So on the right, if you would add these all up, 19.4 plus 14.9 and all the way down, you will get about 100% if you add them up. And that's how it should turn out all the time. The relative frequency should always add up to about 100. Might not be perfect, but it should be pretty close. Okay, next page. Now in example 2, it says, complete the relative frequency table and then make a relative frequency histogram of the 50 Algebra 2 test scores given below. Be sure to label the axis and title the graph. So we're doing the same thing down here. So step 1 will be find the total. And actually, I just realized I forgot to write this. So step 1 is find the total. Step 2 is divide number in class by total. So these are your 2 steps. Find the total, then divide the number in the class by the total. So what is the total numbers of tests? There's 50. You can add them all up. There are 50 test scores we're looking at. So if you want to find the relative frequency, we're looking for what percent. So how many students scored 30 to 39? 3. What percent is that? It will be 3 divided by 50. 3 divided by 50 is 0.06, which is 6%. Okay. Then the next one, how many students scored 40 to 49? That would be 5. So you do 5 divided by the total number of tests, so divided by 50, is equal to 0.10, which is 10%. How many scored 50 to 59? There were 7, so 7 divided by 50 is 0.14, which is 14%. How many scored 60 to 69? There was 11 divided by the total number, which is 50, which is 0.22, which is equal to 22%. And we keep working our way down. 15 divided by 50 is 0.30, which is 30%. And then 7 divided by 50 is 14%. And lastly, 2 divided by 50 is 0.04, which is 4%. So when you add that up, add all these percentages up, we get 100%, which is what we wanted. So we're looking for not how many times do these things happen, what percentage of the test scores are in that category. So then down below we have our table set up. So along the bottom is going to be the test score. And along the side we'll put percent of tests. So what was the test score, and then what percent of the tests were in that range. So if you look at the table above, the test scores go from 30 to 39, 40 to 49, 50 to 59, and so on. So we're going to put these numbers in the histogram. So start with 30, and then 40, and then 50. So 30, and then we need to go up to 100. So 30, 40, 50, 60, 70, 80, 90, 100. So all of our test score classes are there. Then along the side, it's what percentage. So what is the highest percent we have? And it looks like the highest percent is 30%, is in the 70 to 79 range. So you have to go up to 30%. I'm going to go by fives. So if we go 5, 10, 15, 20, 25, 30. All right, and then we just got to fill it in with our bars now. So what percent is from 30 up to 40? So what percent is in this category? It is 6%, so we have to go just above the 5. Okay, what percent is in the 40 to 49 or 40 to 50? Was 10%. So that next one goes up to 10. Then the 50 to 59 or up to 60 range is 14%. So we go up to 14. The 60 to 69 or 60 up to 70 is 22%. We have to go up to 22% and over and down. Then the 70 to 79 is the one that goes up to 30%. So from 70 up to 80 goes all the way up to 30% and over. And then 80 to 89 is 14. So back down to 14. And then 90 to 99 is 4. And then that is what our histogram would look like. So it might look a little differently when you go by percentages instead of just the number of times it happens. It just kind of shows a little different way of how the data can be interpreted.